In the last video, we looked at the steps involved in running a code, which were converting the code into tokens and converting those tokens into an abstract syntax tree. And then we finally collapsed the abstract syntax tree and we finally got the output. So this was the example we looked at earlier, and it is a pretty simple example. But here's the question: how do we know that integer is a valid type, or let's say int is a type and not a variable, or maybe x is a variable and not a type, or maybe equals to is a sign and not something which we can use in a variable? How do we define those rules? The answer is grammar. We know that programming is a communication language between humans and computers, similar to how English or any other language is. So let's take an example of grammar in English itself. So we have a sentence which says Soham is a good boy and Rudra is a lazy boy. So how can we grammatically identify this sentence? So we know that this is a sentence and this is another sentence joined by and. Now there are also nouns and maybe proper nouns, articles, and many other things. Also, the sentence ends with a full stop. Now, similarly, we have to define how a programming language should function. We can apply the same principles in our programming languages as well. The sentence ends with a semicolon, that is equal to sign followed by a number. Before equal to sign, there should be an identifier, and if the identifier is defined in this line itself, it should be there should be an integer type, or let's say a type, any generic type. Also, if it is an integer type, there should be a number and not letters or characters. This is also a rule in the grammar. Now, how can we define the grammar is the question. Because in English there is no such definition of how grammar should work. There are lots and lots of books which we can use to understand how grammar works. In programming there is something called formal grammar. Not just in programming, but in many use cases where computers are being involved, formal grammar is used. Let's consider this example of defining a grammar. It states that digit is something between 0 and 9, which is true. Again, a character is something between capital A to Z and small a to Z. These are some regex-like syntaxes, but you can obviously follow other rules like this. So here we say that a digit is number 0, or it can be 1, or it can be 2, or it can be 3, and blah 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 blah. Now we can use this rule to make different rules. For example, now we can use this digit rule to define some other rules like integer. An integer can be something. Now it is written that integer is digit plus. This plus sign indicates 1 or more, not 0. A digit can be 1 or more than 1. So let's say 0 is a valid number because it's one digit. Maybe 01 is also a valid integer because it's two digit, or that is 0 or 1 digit. But it cannot be left blank because it is 0 or 1. Maybe take another example, for example, of floats. So how can we define floats is, a float can be, we require a digit to begin with. It can be any digits, but we at least want one digit. We cannot start with directly a point or decimal point. We need at least 10. So we can add digit plus followed by a optional point. So let's say 10 is valid float because it's a valid floating point. We can represent 10 as 10.0. So we should accept 10 without the decimal also. So we want this the point optional. We can use parenthesis and a question mark. This question mark indicates that the term in the brackets is optional. After the point, we want some digits. Maybe we cannot leave the numbers blank. 10 point and a semicolon is not a valid solution. So we want something after the point. We want some digit again. We also wanted 0 or 1. So this is the definition we can write for floats. Let's look at some of the rules that we can use. So first, we already saw how a digit can be represented. A digit is nothing but a number between 0 and 9. A character is also between A to Z, and a small a to Z. Now we can define integers as digit plus, that is 0 or more digits, 1 or more digits. Now here float is defined as digit star, that is the first digit is optional, and point is compulsory for float because it is not added, we have not added a question mark here, and then digit plus. So 0.005 is a valid digit in this case, but let's say 10 is not a valid float. So after floats we encounter identifiers. How can we define an identifier? So we want identifier to be at least one letter long. So that's why we have made it compulsory that it should start with a character. A character is nothing but A to Z and small a to small z. So after that, after the first character, we can have digits and we can have a collection of characters. It is optional. It is 0 or more. That is, let's say A is also an identifier because it satisfies this much, and this is just repeated 0 times. Or AA, where first A is defined here and second A can be used as this character. Or A9 is also a valid identifier, but 9A is not a valid identifier because we first want characters, and most of the programming languages don't allow digit to be the first character of a identifier. So let's look at this complex example. Yes, this is little bit complex, but not as complex as other grammar that are written for languages like Python or JavaScript. So how does it start? A program is defined as a collection of statements. It can be 0 or 1 statement. So a empty file is a valid program for our language. What is a statement? A statement is nothing but an expression or a if statement. It is a collection of those. So a statement can be either an expression or if statement, or it can mean nothing, neither of them, and be empty. And what is an if statement? So if statement is defined as it should start with if followed by a comparison operator or a comparison rule followed by an opening bracket. There should be a statement or a collection of statements. It can be 0 or 1, and then followed by a closing bracket. Now what is comparison and what is a statement? So comparison is nothing but an identifier, some operators. Here's a list of operators which are valid in our language, and then followed by another identifier, or let's say in this case integer or float. So identifier equal to identifier is not a comparison in this case. So x equal to 5 is a valid, and x equal to y will not be allowed in this. I don't know why, but yes. Now assignment. So assignment is nothing but identifier followed by equal to sign and then integer or float. And rest of them we have already checked. So this is the language that it can accept. You should get into depth and research about automata theory and learn about it. It will help you to understand how this works, the states, the regular expression, etc.